Alright, so I think I'm recording. We have been looking at relations, and this time in this homework, these relations have been given to us in the form of an equation, and they're asking us to use this equation to find the domain of the relation and the range of the relation. Well, this any time that they give me an equation and I'm trying to find the domain, we've seen that we start out the same way every time. The domain is a set of all real numbers, excluding any values that cause division by zero, and also excluding any values of x that would cause us to take an even root, like a square root of a negative number. Well, for this problem, I don't have any variables in a denominator, so I don't have to worry about division by zero, but I do have a variable underneath a radical. And we saw a problem very similar to this before. Let's go back and see what number that was. Number 5. And so when we started out the exact same way we're going to start out here, taking the expression and making it greater than or equal to 0. Because it's a quadratic equation, we're going to find the boundary points. Those boundary points are going to divide our real number line into 3 regions, and we're going to pick test points and see if the inequality is true or false. But this time, my expression is not quite the same. Last time it was x squared minus 36, so they've changed the order of the subtraction. This time it's 36 minus x squared. So let's see what's going to happen with this. This 36 minus x squared, I need that to be 0 or positive because I'm going to take the square root of it. Since this is a quadratic inequality, I have x raised to the second power. I need it to have on one side 0, and on the other side, I need to have it in factored form. 36 minus x squared factors to 6 plus x times 6 minus x. So even though this is greater than or equal to 0, because I have the equal portion, I focus my attention on it first. So I ignore the greater than, and I think for just a second, well, what are the solutions to this equation? And they're the same as they were last time. Positive 6 plus negative 6 gives me 0, and 0 times anything equals 0. So on the number line, I've got negative 6 and positive 6. So I shade these in because the original inequality was not just greater than 0, but greater than or equal to. It's because of this equal sign here that I make those solid. If this were strictly greater than 0, both of those points right there would be hollow points. But I have greater than or equal to 0. Well, now we saw this before, that this divides my number line into 3 regions. And I'm going to pick values that we call test points in each region. So values that are smaller than negative 6, I may as well just pick negative 7. And between negative number and a positive number, 0 is always a fantastic test point because 0 is always easy to do arithmetic on. I'm the world's fastest at multiplying by 0 and adding 0 to any number. Look it up in the Guinness Book of World Records and you'll find me as being faster than anyone else at multiplying by 0. Give me a number right now, any number. You yell it out and I'll tell you what that number is multiplied by 0. Hey, it's 0. See how fast I did that? All right. So let's return to this original inequality up here. When x is equal to negative 7, I've got 36 minus a negative 7 squared. And the question is that true or false that this is greater than or equal to 0? Well, look at our subtraction this time. We've got 36 minus 49. 36 minus 49 is negative 13. And a negative number is not bigger than 0. This is a false statement. So therefore, since negative 7 doesn't satisfy this inequality, all of the test points in region A would not satisfy it. So I don't shade that in my domain. Well, now I come along and I use the test point 0. I've got 36 minus 0 squared. Well, 36 minus 0 is 36, and 36 is greater than or equal to 0. That's a true statement. So since that's a true statement, I'm going to shade in all of these values that are between negative 6 and positive 6, because if they're true for my test point 0, they're going to be true for any point in region B. All right, let's come over here and finish it. If we look at region C, we have 7, and let's plug that in. 36 minus 7 squared. Well, again, that's 36 minus 49, which is negative 13, and negative 13 is not greater than or equal to 0. That's false, so I'm not going to include this in my domain. So this time, by changing the order of subtraction, we have the test points that were in the middle. So to describe those values, those are in the domain. At negative 6, we were including negative 6, and all the numbers between negative 6 and positive 6, including positive 6. So that's my domain. So, compare that answer to the answer from problem number 5. Now, let's take a look at the graph of this. Oops. Alright, so I've already keyed this in, and here it is. Well, let's go back up. Last time, you can see the graph was out here. This time, it's looking like a semicircle. Okay. This range will be easy to determine. Both of these endpoints have the same y-coordinate. They're both 1 unit below the x-axis. So over here, when x is 6, this y value is negative 1. That's what I'm interested in, is that minimum y value right there. And over here, at negative 6, this point has the same y value, negative 1. And then all of these points that are on this graph are all bigger than negative 1, but there's a maximum up here. When x is 0, y is 5, and there's no point above that point. So my range this time is sandwiched between these two values. It has a minimum value of negative 1 and a maximum value of 5. And all of those, we don't see a hollow point at the end right there. So these are brackets. So there's my answer for problem number 8. Hope that helps.